Hello everyone and welcome back to Education Foundation. In our previous video, we looked at this question on the first part of this question, which told us to calculate the stress in each sample, that is the stress in the mild steel and the stress in the aluminium. So now in this video, we are looking at the second part of the question where they said that the temperature of the compressed composite bar is reduced to 90 degrees Celsius, but no change in length is allowed. We are expected now to calculate the stress in the bar and in the cylinder. That's expected to calculate the final stress in the bar and the cylinder. So let's move over to that. It's important to recall that due to a change in temperature, where in this case the temperature is decrease or the temperature decreases or there is a decrease in temperature, full change of length is allowed. The strain of steel and aluminium in this case will then be equal. So here, this the strain of steel, which is then represented by this symbol, is then equals to the Young modulus of mild steel times the linear expansivity of mild steel times the change in temperature of mild steel. While for the stress in aluminium is then equals to the Young modulus of elasticity of aluminium times the linear expansivity of aluminium times the change in temperature of aluminium. So you should take note that the change in temperature here is for both of them, that is the stress in steel and aluminium is equals to 90 degrees Celsius as given in the question. So let's substitute our value. So let's take note of what all of these other values stand for. So we should remember that the Young modulus of steel is equals to kilonewton as given in the question per millimeter square. The linear expansivity of steel is equals to 0.0000012 per degree Celsius. Then the Young modulus of aluminium is equals to 80 kilonewton per millimeter square, and then the linear expansivity of aluminium is equal to 0.000005 per degree Celsius. So now that we know what each parameter stands for, so now let's start by finding the value for the stress of steel. So when we substitute our value, the stress of steel will then be equal to 200 times 10 raised to power 3 times 1.2 times 10 raised to power minus 5 times 90. So when we input this into a calculator, it will give us 216 Newton per millimeters square. So now let's find our value for the stress of aluminium. So when we substitute our previous parameters that we stated in the earlier part of the video, it will be equals to 80 times 10 raised to power 3 times 5 times 10 raised to power minus 6 times 90, which will then be equals to 36 Newton per millimeters square. We should take note that this 1.2 times 10 raised to power minus 5 is still the same thing as 0.00001.12 as we stated earlier part of the video. Similarly, the linear expansivity of aluminium is still the same thing. The only difference is we substituted the standard form value for the two linear expansivities. So now we are now going to look for the final stress in the steel bar and aluminum cylinder, which is then equals to the final stress for the steel bar, which is S total, which will then be equals to symbol, the one that we got in this video, minus this symbol, this stress of the steel bar that we got in our previous video. For the total stress or the final stress in the aluminum bar will then be equals to the stress that we got in this video minus the previous stress that we got from our previous video. So we should take note of the following parameters in this formula that we have here. So from this video we have gotten that our value of ES is equals to 216 Newton per millimeters square, and our value of EA will then be equals to 36 Newton per millimeters square. So in our previous video we got our value of the stress on steel, which is then equals to 106.90 Newton per millimeter square, and then we now got our value of this symbol, which is representing the stress on aluminium, as 42.80 Newton per millimeters square. So if you substitute the following parameters into the equation above, we are going to get our final stress in the steel and aluminium. So our final stress for the steel, when we substitute the value, will then be equals to 216 minus 106.90, which is then equals to 109.10 Newton per millimeters square. Then now, sorry, here I forgot to write total. Then now, our final stress for aluminium, let me write total here, would then be equals to 36 minus 42.80, which is then equals negative 6.80 Newton per millimeters square. So therefore, the final stress in steel and aluminium are 109.10 Newton per millimeter square and negative 6.80 Newton per millimeter square respectively. So this is to say that the final stress in the mild steel bar is 109.10 Newton per millimeter square, which indicates a tensile stress, while the final stress in the aluminium cylinder is negative 6.80 Newton per millimeter square, which indicates a compressive stress in the aluminium cylinder. So if you found this video helpful, don't forget to like, subscribe, and drop your questions in the comment section below. Thanks for watching and see you in our next video.